So hear me out. So first of all, let's make a point here. Let's take this point as O, and let's make a line segment. Just make a short line segment here, naming AB. Okay. So we have the point O, and we have the line segment AB. So as you know, there are infinite points on this line according to the properties of a line segment. So there are infinite points which can be marked in this line segment. So let's suppose we mark this point M1, we mark this point M2, we mark this point M3, and we mark many more points, and we mark continuously many more points here and there, and like M1, M2, M3, M4, M5, and then we just try to join them using to the point we have. Just a second. Yeah, so as you can see, the lines might not be exactly straight, but as you can see, um, the distance from point O to A varies in all scenarios, because as we know, one is a slanting line, and according to the properties of a right angle triangle, the hypotenuse, the value of the hypotenuse is changing, because if we make an imaginary right angled perpendicular here, so the distance of the hypotenuse will differ, because the length of the base from this imaginary perpendicular differs from all points. But then we have to define a certain distance from the line segment to point O. So that will be the perpendicular. The perpendicular we're talking about, which we'll take it as O. So in mathematics, we define this length O to O, O1, O2. Let's take it as O2, not oxygen. O to O2. So O to O2 is basically the distance from the line segment AB. Because if we consider all these points as distances, then we won't have a specific distance for this from the point to the line segment. So we define the shortest distance from this point to the line segment, and it's mentioned in this paragraph, and you can just pause and have a look. It's a very fundamental principle in mathematics, and you should be aware of it. Thank you very much.